Alright, so let's see how we got here. So the tool that you just saw was a waypoint drawing system that I have set up that uses a new trick that I found out about, which is execute in edit mode. And execute in edit mode is a cruel mistress. The waypoint drawing system uses a few different methods to draw lines. I have a method to draw Bezier curves, and I have an intersection sort of stamping tool. Don't want to do this during play mode, so if the application is actually playing, then I disable the update loop. These are our booleans that I'm using to execute in edit mode and do the drawing. So if I am creating an intersection, we go through and run this method and create the intersection. I do have a script that goes through and automatically cleans up all my problems. What I have found is that the only thing that I need in order to make this directional, that is to say, you're driving traffic on the right side of the road, is the intersections. The intersections need to be directed. For this curve here, this is the end point of the line. This waypoint here is the end of a line. But this is the start of an intersection. And if we pick a point in the middle of the intersection, you'll see that it only has one neighbor. And the reason for that is we want the directionality of this to go this way. So this waypoint's only neighbor is this next waypoint. So If we were to navigate from somewhere over here and want to get over here, it's going to actually loop around and head on over here. Right now I have the waypoint set up in a parking garage. Qualifier in my navigation that says that you have to enter parking garages through the parking entrance. The location I'm at right now doesn't demonstrate that very well. So I'm going to go ahead and move this guy over here and show you that it will not path this way and head through here. It will instead make its way around this way, come around, and have to come in through this way. Go ahead and unpause the game, and as you can see, he heads around, and the shortest path to get to this point would have been to go directly there. But instead he followed the traffic rules because our intersection is directed. He went the proper way. This is much cleaner than it looked in the making because all of these lines were populated with waypoints. And part of the way I'm cleaning up my map is by deleting all of the waypoints that are in the middle of lines. I only need 2 points to define a line. The way I'm fixing the maps is to replace every instance of the intersections with a brand new instance that's directed, and then the endpoints just need to get the neighbor, and they also need to add themselves as a neighbor to the intersection. In the future, if I end up having to put a point in the middle, I'll figure something out. I've got a little map here which consists of 2 lines. The 2 lines have 3 points apiece, and we also have the 1 intersection which consists of 2 more lines. I can go ahead and reset this intersection to show you that step. We're in play mode, sorry. Let's get out of play mode. If I go and reset this, you'll see that it breaks those connections. These 2 are no longer neighbors. You can see that if we move, the line doesn't follow because they're not neighbors. The rest of the script, as you can see, we reset the intersection, and then we do this thing called add hub neighbors or set hub neighbors. That's the endpoint as a neighbor of the end of the intersection, and it also adds that point as a neighbor to the end of the intersection. Go to map, reset map, and as you can see, it has connected our endpoints, and it's also gotten rid of the middle points of our lines because they're unnecessary. You can see that no matter where I move, we're still going to navigate to the point. And that is because when we navigate positionally. So it really doesn't matter where the neighbor is. Once you've made your map, you're able to move these points freely. The collider at that point doesn't mean anything. The collider's simply a tool to allow me to set the neighbors for everything. That's pretty much it for the map. We go through and draw our intersections, draw our lines. We've got extra waypoints in the middle. I use my nice little script to go through and reset those so that the map is navigable properly. I started working on this when I got far enough along in serialization of my data that I felt like I could start making some function calls and testing out functionality of the game. If we go into what I'm calling effects, you can see that I have an effect scraper. And what that does is it goes through and it analyzes the functions in effect. And in effect we have one function, move to, and we have the move to that we are storing in our dictionary. In affects a dictionary of delegates. And what this is allowing me to do is call these functions by constants. I have a list of constants that's generated by my scraper It pulls out all of my functions. Whenever I call a function with my data, I use the effect args class, and that allows me to use this property drawer. Another huge thing that I have implemented in this, which is a property drawer. I can pull any set of keys with this set of constant. This allows me to make keys. Every single one of these has a key ring, and these keys are what I use to populate my dictionary. As you can see, I don't have any resources, but I have gone through and serialized all the data that I need to create all of the companies in my game so far. So in my dictionary, you can see I have a lot of property drawers, and those property drawers are the exact same as the property drawer that I have here, except I only have one function for this property drawer. My dictionaries with like more data in them, I have more items. You can see I have here an attorney. You have resources that you have. There's a receptionist as a job. There's a lawyer as a job. And we can go into jobs and we can see what that job is. So we have a receptionist, and it's a level 2 job, and it has the requirements of savoir-faire and abilities that you get from the job. This allows me to serialize objects and pull them out of this dictionary and create them on the fly without having, as you can see in my map, 100,000 game objects. If I wanted to instantiate a vehicle, I would create a vehicle instance. This is my public vehicle. Here you can see I have a coupe. It's got a few different inventories, and I don't have to have those as game objects in my dictionary. I can have them as serializable data, which in this case is a string that I'm using as a key. Think of it sort of like a database. Making a key, execute in edit mode to create new entries in my dictionary, and then using those dictionary entries in order to generate my objects seems like a pretty amazing way to go, so that I don't have 100,000 prefabs. Did I mention it also serializes the data? So I can see all this data. I can see everything that my vehicle needs. This brings me back to effects. I have effects, but there is no serialization of those delegates. I found out that you can't serialize delegates. There are methods to be able to do this. Right now I generate them at runtime. If I go ahead and push play, you'll see we create the delegates on startup. I have a ton of serialized data. I have some constructs in place to generate objects from that serialized data. We got a nice map system. And one more thing that I have is a time tick system. It's a great way to avoid the update. I found this little snippet here, and I have expanded it into an update tick and an on tick event. And this is the timer that's in the game right now. It's resource ticking in sync with the time. But you can see, I'll show you how amazing having one function deal with your updates is. All I have to do after I have found my path to navigate, I add this on tick, this time tick system on update delegate. I add my on update, which is to navigate. So every time our time tick system ticks, and it ticks every update, the path manager automatically decides to navigate, move to the next waypoint. Now, what's so great about this is that when I'm done, I can remove that delegate. So that means that I don't have to have an update in my navigation manager. Everything is controlled by the time tick system, and I don't have to have an update method. Not having an update method on all of your items is amazing. Let's say I have 1500 things navigating on screen at one time. Once they've stopped, they're going to continue running the update method to check variables to see if they need to do anything. Even if there's nothing there, it's still using resources going through the update. It's doing that one check to see if you need to navigate. With this method, you only have the update method when you need the update method. Unless you really need to check something every frame, there's absolutely no way that you need an update method. I know it's been a long time, but I've done quite a bit in that time. I've serialized all the data. A lot of data. I've made dictionaries. I've made the waypoint pathing system. The dictionary call is actually how we navigate. You see that here. This is another coroutine. We invoke the effect, item args. This is why serializing that data is so important. We're invoking this effect, which is a string, to pull from our dictionary of effects, which, as I said before, isn't serialized, so you can't see that. But trust me, it's calling that effect. So effects, and we find invoke effect, passes a key and the args, and we just get the dictionary entry for that delegate. It's pretty amazing. This way we can call delegates by strings. If our keys are strings, that means that we can call any method that we want with a string. And using this dictionary method, none of our keys are going to be the same. And this way we create a system that is defined through serialized data, and all that serialized data refers to each other in order to make that functionality happen. There's no switch statements. There's no really long decision trees. We know what we want to do. We call the method that we have with a key, and we pass the args that we need to. And I think it's worked out pretty good so far. But yeah, I hope you guys like that, and I'll see you when I see you. Thanks.